What is a derivative? Derivative is a core of calculus and modern mathematics. Also, derivatives is also known as the instantaneous rate of change. What are the various applications of derivatives? We can apply derivatives in various fields. For example, engineering, physics, education, life expectancy, and population. Why do we need to study derivatives? We need to study derivatives because this may help us predict a lot of things. For example, life expectancy, the trajectory of an object, and many more. What mathematical skills are needed in order to solve derivative problems correctly and more efficiently? There are two skills required in order to solve derivative problems. First is that you should have a basic knowledge about algebra. Second, you should master the derivative rules.
Hi, good day. Today, we are given a problem about a tangent line. So here is the problem. Find the equation of the tangent line to the curve which is parallel to the line y is equal to x. So the given are the equation of the curve which is y is equal to negative 2 over x minus x plus 3. The equation of the parallel line which is y is equal to x. So here are some essential information that we could use in order to solve correctly the problem. First is the point slope form, which is y minus y sub 1 equals the slope times x minus x sub 1. Next is the power rule, which is getting the derivative of x raised to n, which is equal to n times x raised to n minus 1. So there are 5 easy steps in solving this problem. The first step is get the slope of the line parallel to the tangent line. So the equation of that line is y is equal to x. And the slope of y is equal to x is equal to 1. So the second step is find the derivative of the curve. So the equation of the curve is y is equal to negative 2 over x minus x plus 3. We can write this function into a simpler form, which is y is equal to negative 2 times x raised to negative 1 minus x plus 3. So let us now get the derivative. So we can use the product rule in order to get the derivative of negative 2 times x raised to negative 1. We just need to multiply the exponent to the base and deduct 1 to the exponent. So here it is. Now let us get the derivative of x, which is 1, and the derivative of a constant is equal to 0. So we just all need to simplify this equation. So the first derivative or the slope of the curve is 2 over x squared minus 1. So the third step is equate the slope of the parallel line to the slope of the curve. We need to equate them because we need to find the point in which the tangent line touches the curve. So here are the two slopes. So 2 over x squared minus 1 is equal to 1. We need to multiply x squared on both sides. So x squared multiplied by quantity 2 over x squared minus 1 is equal to 1 times x squared. So the 2x squared will cancel, and x squared times negative 1 will be x squared. So here it is. Here's a simplified form. So we need to isolate x in order to get its value. So we need to transpose negative x squared to the other side. So here it is. So 2 is equal to x squared plus x squared. We will add the 2x squared. So 2 is equal to 2x squared. So let us divide both sides by 2 to get the value of x squared. Then we get the square root of 1. The square root of 1 is positive and negative 1. The fourth step is substitute x is equal to positive negative 1 into the equation of the curve. So for x is equal to 1, here is the equation of the curve. So let us substitute x is equal to 1. So y is equal to negative 2 over x over 1 minus 1 plus 3. So let us now simplify. So y is equal to negative 2 minus 1 plus 3. So the value of our y is equal to 0. Now, we have the first point of tangency. So for x is equal to negative 1. y is equal to negative 2 over negative 1 minus negative 1 plus 3. So we just need to simplify this equation. So y is equal to 2 over 1 plus 1 plus 3. So y is equal to 2 plus 1 plus 3. So the value of our y is 6. Here is the second point of tangency. Yahoo! We are now on the fifth and final step. So the fifth step is use the points to determine the equation of the tangent line. So for 1, 0, we can use the point slope form. So we are now going to substitute. So y minus 0 is equal to 1, which is the slope of the parallel line, times quantity x minus 1. So we are going to simplify. So y is equal to 1 times quantity x minus 1. So y is equal to x minus 1. This is the equation of the first tangent line. So for negative 1, 6, y minus 6 is equal to 1 times quantity x plus 1. So we are going to transpose 6 in order to isolate x. So y is equal to 1 times quantity x plus 1 plus 6. So here it is, y is equal to x plus 1 plus 6. So we just need to add 1 and 6. So the equation of the tangent line, the other tangent line is y is equal to x plus 7. So now, I will present to you the two tangent lines. So the first tangent line is y is equal to x minus 1. The second tangent line is y is equal to x plus 7. Now, we have solved the problem. Very good! I hope that you have learned a lot of things from me. Thank you! See you again next week for another episode of my Calculus Vid. Bye!